So from here, okay, remember the first one. Rn can be written as a direct sum of S and S orthogonal, right? So we know that, okay, from number one, okay, so we can say V is U plus W, where U belongs to R and the W belongs to R orthogonal. And right? V has a unique representation of U plus W, where U belongs to S and W belongs to R orthogonal, right? Okay, from the first statement. Okay. So let's examine. Okay. The trick here is that if W is zero, then V equal to U, which will be an element in R, then we have a case, right? Right? That's the trick, right? That's the trick. So how do we do it? Okay. Let's do it this way. Let's do W dot V. Let's do an inner product of, we do an inner product of W to V. And then what happens is that this is going to be W dot U plus W dot W, right? Right? First, this V comes from here, right? V comes from S particular, S orthogonal. So W comes from S orthogonal, right? So the element in S orthogonal must be orthogonal to S, any element S orthogonal. So this one is zero, right? Right? And also W and the U, okay, this W is in R orthogonal. This U is in R. So this one, the inner product is also zero. So, what it tells us that is that, well, W dot W or W norm is zero, right? So it means W is a zero vector. So if W is a zero vector, it means V equal to U, right? Because W is zero vector. So V equal to U. V equal to U, then here, our U is an element in R, right? So it means that V is an element in R. So from V is an element in S orthogonal, we can derive V is an element in S. So we have the second. Okay, so we have the third statement. Is it okay? And any question? 有没有问题？看大家都不讲话，是在准备那个小考，还是在那个听课啊？我其实理论上是希望说上课前，就是等于说上课开始的时候给小考 ，OK， 这样至少你们在听课的时候会更专心一点，或者说你们，或者说那个考完了就跑掉的也没有关系，对啊，这个，对啊，就是反正留下来听课的可以专心听课 ，OK，but well because today I have to admit the quiz today just like the last time, okay, it has been a while, right? 至少2个多礼拜吧，对不对？2个多礼拜。就像上次那个小考一样，也是2个多礼拜。Okay, so that's why okay I gave more questions this time. So I will give you like 1 hour, well 15 minutes, okay, time for the quiz. Okay, so you have plenty of time, but it's just there are I think there are like 5 questions. Okay. 所以 because of that, so I think like, it's probably a better idea that I will give you the quiz in the 3rd lecture. Okay, in the 3rd lecture. Oh. So then, we need to discuss the projection. Okay. I think here is this. This topic actually has something, also has a lot to do with the next section. Okay. So, okay, first is the definition. Okay, let S be a subspace of Rn. Okay, we know Rn can be written as the direct sum of S and S orthogonal for any V in Rn. Okay, we have V equal to V1 plus V2. Okay, for some unique V1 in S and V2 in S orthogonal. We already know that. Okay, so the vector V1, okay, is called the projection, okay, of V onto the subspace S. Okay, it's denoted as V1 equal to project, okay, S to V, project S V. Okay, so basically that's like a notation. Okay, so basically, what does that mean? If you try to imagine I mean, in your high school, like you learn geometry, right? Like 那个三维空间嘛，高中的时候学三维空间、2维空间、3维空间，对不对？对不对 ？Okay, so so if you have a plan, plan, let's just imagine this plan is a subspace here. It's a subspace here. Okay. I mean, in a higher dimension, I mean, of course we will call it this hyperplane, but you get an idea. So for any vector, you can project this vector to this hyperplane, right? Okay, so this is like this is V1, this is V2. where V1, V2 are perpendicular. And the V1 is in S. And the V2, okay, is perpendicular to this hyperplane. Okay, or you can say it's V2 is an element in R orthogonal. Okay， 你可以用这样的方法去理解这个东西。那 then if you understand this, then this V1 is the projection of V, okay, onto this this subspace S, okay, or hyperplane S. Okay, so it's actually very, very easy. So how do we how do we do it? Remember, previous we used this one, right? If we have an orthogonal basis, like W1 to WK, then this V1, this is actually, the V1 is in, S. Is in S because this is a linear combination of bases in S. Okay, so if we go one step further, okay, if we let V1 to Vk to be orthonormal basis, what is orthonormal basis? You guys previously already discussed what is orthogonal basis. Orthogonal basis just means like all the vectors, all these k vectors, they are orthogonal to each other, right? That means it's an orthogonal basis. Okay, for orthonormal basis means these vectors, they are not only orthogonal to each other. I mean, each of them is a unit vector. Each of them is a unit vector. Okay, so the projection of V onto S, okay, so V dot V1 plus V dot V2, blah, blah, blah. So how come we have such a very tidy and a very clean format? It's because basically, okay, if your W1, W2, all these WK, they are orthogonal. If they are not orthogonal, as long as you have if they are orthogonal, okay, you can make an orthonormal basis from an orthogonal basis. Basically, just for each vector, just divide their length, right? Okay, just make sure that if it's too long, you can divide their length. If it's too short, extend it. Then basically divide the length. Okay, that's it. So you see, this is how we project the V into the S. Okay, we already used this idea, but because here it's an orthogonal basis, so we have to keep this denominator. But if they are orthonormal, each of these will be 1, right? These denominators will be 1. So what does it mean? It means like, you don't need to write the denominator. 就是它的分母都是1嘛，因为它们的长度都是1，对不对？所以它们分母都是1，所以你就不用再写，所以就是把那个 Wi 换成 Vi， 你就得到这个东西了，对不对？I mean, you can easily show that this is a vector, this is a vector in S because it's a linear combination of D1 to Dk. Okay, and we know V1 to Dk is also normal basis for S. Okay, and you know, any vector in S orthogonal is we already showed is orthogonal to this vector anyway. Okay, or you can say that okay, any vector in V minus any vector any vector V in Rn, okay, you can write it as V equal to and we know this V prime will be an element of R, S orthogonal. We already showed this earlier. So but the following is like a more interesting. Okay. Let S be a subspace of Rn and V in Rn